In the previous video on solving systems of equations, we took a look at the graphs of a system and found that the solution is the point where the lines intersect. In that video, we also looked at solving systems using the substitution method. In this video, we'll take a look at the elimination method. The elimination method is also referred to as the addition method. Both of these are good names because we're going to look at adding the system together and hoping that one of the variables will eliminate. And we're not just going to hope, because if one of the variables is not eliminated, we're going to manipulate our equations so that one of the variables does eliminate. So let's take a look at this system. We've got 3x plus y is equal to 2, and 2x minus y is equal to 3. Thinking ahead a little bit, if we were to add these two equations together right now, the y's would cancel out. So we don't have to do any extra work. We can just go forth and add the two equations. 3x plus 2x is 5x. Y minus y cancels. Bring down your equal sign. 2 plus 3 is 5. Divide by 5 on both sides, and we get x is equal to 1. Then we have to substitute our 1 in for x in either the first equation or the second. It doesn't matter. I choose to substitute it into the first. So this gives me 3 times 1 plus y is equal to 2. 3 times 1 is 3 plus y is equal to 2. Solving for y, we subtract 3 on both sides. 3's cancel and we get y is equal to negative 1. So our solution is the ordered pair 1, negative 1. So with the elimination method, we're adding the system together so that one of the variables cancels. In this next equation, we see that we have 3x minus y is equal to 5, and 2x minus 3y equals negative 6. Think ahead a little bit, and if you add these together right now, you'll see that nothing cancels out. So then I have to decide, okay, do I want to eliminate the x's or do I want to eliminate the y's? Well, in my opinion, eliminating the y's is going to be much easier because in my top equation, I just have a minus 1y. And I need that to be a positive 3y so that when I add it to this negative 3y, they cancel out. So remember, we need the opposite signs but the same coefficients. So what I'll multiply my first equation by is just a negative 3. Multiply all the way through, that gives me negative 9x plus 3y equals negative 15. I'm going to rewrite my second equation right underneath my red equation. 2x minus 3y equals negative 6. And now that I've manipulated the first one, I'm ready to add these two together. Negative 9x plus 2x gives me negative 7x. 3y minus 3y cancels, which is what we want to happen. The y's are now eliminated. Bring down your equal sign. Negative 15 and negative 6 makes negative 21. Divide by negative 7 on both sides. Negative 7's cancel, and x is equal to positive 3. There's half our answer. Then we have to decide where to plug it in. Now we have to substitute the 3 in for x in either the first one or the second one. It does not matter. I'm going to plug it into the second equation just because I plugged it into the first equation before. So I'm going to plug it in right there. That gives me 2 times 3 minus 3y equals negative 6, giving me 6 minus 3y equals negative 6. Subtract 6 on both sides. 6's cancel. Negative 3y equals negative 12. Divide by negative 3 on both sides, and we get y is equal to positive 4. Final answer, 3, 4. Now, the ACT is notorious for not necessarily asking you to find the solution, but they may ask you to find the product of the solution or the sum. So be ready to actually multiply or add your coordinates. So just look out for those questions. And let's take a look at one more elimination. Here we have 3x plus 2y equals 6 and 3x plus 2y equals 1. Now these look very similar at first glance, but remember if we add these together, we want to know if one of the variables cancels. Well, if I add these together right now, nothing cancels, but they're pretty darn close because the x has the same coefficient and the y's. So I need some opposite signs. So we're going to multiply the top one by -1. You could have multiplied the bottom one by -1. It doesn't matter. I just chose the top one. And remember, multiplying by -1 is really just changing all the signs. So you could just change. But I'm going to show you the steps here. You just distribute it. That gives me -3x minus 2y equals -6. I recommend bringing the other equation over. You really want to keep your terms lined up since you're going to be adding the equations together. Add them up. The x's cancel, the y's cancel, so you're left with a 0 on that side. But on the other side, you're equal to -5. So when your variables cancel out, you know it either has to be no solution or infinitely many solutions. And because 0 is not equal to -5, that's not true, that means this is no solution. If we were to get the same result in the fact that the x's canceled and the y's canceled, but say we got 0 equals 0, then in that case, the answer would be infinitely many solutions. So I just wanted to make sure you saw what would happen if you got one of your special cases. But in most situations, your answer is going to be an ordered pair.